let's do an example where we're going to use a concave mirror, and the distance from the object, the distance from here to here, is very much greater than f. So f here, f is equal to 6 centimetres. DO is equal to 18 centimetres. And I've made the height of the object, height O, is equal to 5 centimetres. Now, let's try this. I'm going to deal with a concave mirror. So there's my line, neutral line, there's my line of action. I draw in the shape, and that just tells me what I'm dealing with. And when we're dealing with these, remember with the mirror there's two lines we draw in. Line 1 goes parallel, then through F. So what I'm going to do here, I grab a ruler, so I know it's 5, it's going to hit here. Line 1 goes parallel, so draw that in, bounces off the mirror, and then it goes through, reflects through F. So we imagine a ray of light physically goes from here, goes here, bink, and down through F. Ray 2, remember number 2, goes through F, then parallel. So for number 2, I grab the ruler, and I'm going to hammer this because this becomes important later. We put one part of the ruler on the arrow, top of the arrow. We put the other on F, wherever F may be. And I draw through there, and I hit there, boink. And then I go through here, so it goes from there through there, and then it goes parallel. And as we can see, the lines cross here. So this is where my image is going to be. So we can look at this as I said, there's 3 questions we ask: upright, inverted, and I can look at this and I can say this image is inverted, it is upside down. We go enlarged, reduced, and again we look at that and go that's smaller than that, so it's reduced, and we go is it real or is it virtual? If I put a piece of paper there, can I shine it on the piece of paper? And the answer is, well, these lines are solid. Remember, this is the quick and dirty way. If we have just use solid lines, that's going to be real. And then if we want to, we can measure height of image. We can actually physically measure this because I've set up a scale. This says it's 2.5 centimetres. And distance of image, we can measure that from the mirror to the, it says it's about 9 centimetres. Another way we can do this, because humans are not always perfect, we can actually also use math on this. So remember that lens equation we had before? F is equal F inverse is equal to DO inverse plus DI inverse. If I want to find out DI, I rearrange this. So minus DO inverse, DO inverse. So it cancels that. DI inverse equals F inverse minus DO inverse. Then I want to go, I take the inverse of both sides, inverse. So basically, I go minus 1 to the side, gets rid of that, and I just can take that across. So equals, what's that going to be? 18 As long as they're all in the same unit, it doesn't matter if you use centimetres or metres or inches or lines or... So 18 inverse minus, that's equals F is 6 inverse minus DO is 18 inverse, all to the minus 1 equals, calculator time. So where we go, as if you want to use the brackets and things, you can go bracket 6, and there's an inverse button on your calculator up here, 6 inverse minus 18 inverse, close brackets, take the inverse of the whole lot, equals 9 centimetres. I did a good job drawing there. Okay, the height of the image, well, we can work this out from height image over height object is equal to distance image over distance object. So what do I want to find out? I want to find out height image equals height times di over do equals height object is 5 centimetres, di is 9 centimetres over 18 centimetres equals 2.5 centimetres. Cool. Now we can work out the magnification. Magnification equals HI over HO, which is equal to HI, we worked out it's 2.5 centimetres. HO is 5 centimetres, equals 0.5. So that means that it's half the original size, so that means it's reduced. This number is a positive number, so it's inverted and it's real. Just looking at the ray diagram we can tell it's real.